I need you to clear your desk, and I just want you to pay attention to me. We have a fun lesson planned. I do have one short announcement to make before we get started. This Saturday, we have Super Science Saturday for tax preparation. 9 to 12. And I tell you, there are 3 important reasons why you should go. Number 1, you will be better prepared to get commended on the test. And that's what we all want, right? Yeah. Number 2, there's free food. Number 3, and probably the most important reason for coming on Saturday morning to learn more about tax is that you get to see me. How many times have you gone home on Friday and thought, dang, I have to wait 2 more days to see Dr. A? I'm doing this for you. Because I care. You're right. So you get to see me 6 days out of a week instead of 5. You mean I'm not enough? There has to be extra credit?
Yes. No. Are you giving extra credit? Yes.
No. I'll tell you what, you go and then I'll think about it. All right? Okay, now what I'm going to do is I'm going to have you just turn your bodies this way, and I'm going to be teaching off here. And Emily, can you come up here? I've got Emily as my helper.
Does it matter?
Huh?
Good and green.
What color?
You pick.
Orange.
Orange. See what I have here? I have a tennis ball. Why is that tennis ball sitting still? Is it because of the hole? Why is it sitting still? Rhymes with forces. Oh, there are forces that are involved here. What are the forces that are acting on that tennis ball to make it stay still? All right, so I've got the weight, and the weight acts down, and I've got a normal force provided by the table, which acts up. Right? Now, what would happen if I took this tennis ball and put it in a tub of water? So besides getting wet, what is causing that tennis ball to stay still? Because I have a different surface than this tabletop here. Do I still have the same forces involved? I do, don't I? So what is it about the water that's providing support to the tennis ball? Density. Density. How many of you know what density is? How many of you know of density? How many of you are very comfortable with density? How many of you are experts in density? Okay. So density is a simple relationship defined as mass divided by volume. Does anybody know what the density of water is? 1.0 grams per cubic centimeter. Is that a pretty large number? It's a small number, isn't it? Does that small number of density, that value, does it really mean anything? If you were to see a number this small, a value that small, would that indicate to you that we're dealing with a light substance? Something that's not really heavy?
Yes.
No. It doesn't matter about density because density, if you have a little amount, it can be light, but if you have high density.
But, okay, I'm talking about water. So water has a density of 1 gram per cubic centimeter. So does that mean that water is light?
A lot of water.
Oh, I could have a lot of water and I'd still have the same density. So it doesn't necessarily imply that I'm dealing with a heavy substance, does it?
No.
No. So here's what I want to. I have 2 cans of Mountain Dew. One's regular, one's diet. Are these the same? Are they same in size? Same in shape? What about same in mass? They feel like it? So let me ask you this then. When I put this in water, what do you think is going to happen?
Sink.
It's going to sink? How many say it'll sink? How many say it'll float? How many of you are too lazy to raise your hand to even vote? Somehow that doesn't surprise me. Actually, I'm going to have Emily do 2 things for me. She's going to be keeping count, and I'll tell you what this is in a second. Emily, would you mind putting the regular Mountain Dew in the waters? Let me move the tennis ball.
Okay.
Go ahead. So what happened?
It's sunk.
It's sunk. Now, I have a Diet Mountain Dew, and according to Sarah, Sarah is a very reliable, knowledgeable source, right?
Right.
She said that not only do they have the same size, same shape, about the same substance, she also said that it had about the same mass. So if it has about the same mass, what would you expect to happen if I put this in the water
It's
tub?
gonna float.
Really? How many think it's going to sink? How many think it's going to float?
Whoa. Miracle.
So why is this happening?
It's magic.
Well, the only difference that I know between the 2 would be what? One's diet, one's not. And if one's diet and one's not, that means that there is a difference in what? Sugar. 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 You look at the carbohydrates on the menu on the back, and what does it say?
One is like 43 grams and the other one is nothing.
Absolutely. So here's what I want to do. I want to do an experiment and see how much sugar would it take to sink the Mountain Dew diet can. So what I'm going to do I have different sizes of sugar. And let me tell you what we're going to do. What I'm going to do is I'm going to have Emily drop each one of these. One bag has 1 packet of sugar. One bag has 5 packets, 10 packets, 25 packets, 50 packets, then 100 packets of sugar, 2 pounds, 4 pounds, and 10 pounds. But before I have Emily do that, what I'm going to do is I'm going to hand out an index card to each one of you. And what I would like for you to do is tell me which amount of sugar do you think it's going to take to sink? Which one of those bags will sink? Now, I don't want you to discuss. This is an exercise just for you. You tell me how much do you think. And what I want you to do is write out this symbol here. Now, to show you how this is going to work, I'm going to give you a freebie.
How many grams in a package?
Hang on one second. I can tell you that in 100 packets of sugar, there is 354 grams. So if there's 354 grams per 100 packets of sugar, there would be about 3.5 grams per 1 packet of sugar. So what I'm going to do is have Emily demonstrate what we're going to do. This is a freebie one, because I don't think 1 packet of sugar is going to sink. Do you?
No.
Emily, can you just put it in there? Yeah, with the bag. All right. So we know that 1 packet is not going to sink. I mean, come on. Did anybody think it was going to sink?
No.
Good. Okay. So does everybody have an answer? Okay. Now, Emily, can you come up here? So what I want to do is I want to get a show of hands. If you picked 5 packets of sugar, could you please raise your hand? That it would sink. That 5 packets of sugar will sink. Okay, just put a 0 there. How many think 10 packets of sugar will sink? Wait, hold your hands. 1, 2, 3. All right, 3. How many think 25 packets of sugar will sink? 1, 2, 3, 4, 5, 6, 7, 8. 8. How many think 50 packets of sugar will sink? 1, 2, 3, 4, 5, 6. 6. How many think 100 packets of sugar will sink? 1, 2, 3, just 3? All right, 2. Put 2. How many think 2 pounds of sugar will sink? 1, 2, 3, 4, 5, 6? Put 6. How many think 4 pounds of sugar will sink? 1, 2, 3. All right, 4. How many think 10 pounds of sugar will sink? All right, change this to 3, and then put. All right, put 1.
If we think any of the above will sink, then we also think that everything is like.
All right, so we have our votes tallied. Now we're going to do the experiment, and let's see what happens. So, Emily, I'm going to ask you first of all to take the 5 pack of sugar. Yeah, it's on. Just put it back. All right, so 5 packets of sugar. Let's see. Will it sink? No, 5 packets of sugar didn't sink. But that's okay because nobody voted for that. So now let's go to 10. 10 packets of sugar.
No.
No. Still didn't sink. The next one is 25 packets of sugar. 8 of you said it would sink. Go ahead.
There's no air in the packages, there?
I made sure that they were sealed tight. All right, now the next one is 50 packets of sugar. Still not sinking. What is it, guys? I thought you knew about density. All right, 100 packets of sugar.
You count all those, Dr. H.
I did, I counted. Still not sinking. All right, let's go to the bags. Let's go to the bags of sugar right here. 2 pounds.
Exactly.
Oh my.
2 pounds isn't working. All right, so then it must be 4 pounds, right? What is going on here? Now do the 10 packets. Do the 10 pounds of sugar.
Yeah, it's the density that's keeping it up. I said none of them.
You got it right.
Yeah, that's what I said at first, and then I realized it.
Okay, but let me ask you this then. Why did you say that none of them would sink?
Because of density.
Because the density depends not on the amount of the substance that I have, it depends on the substance itself. So I could put any amount of sugar in that tub, and what would happen? Let me ask you this.
Then why does the one?
This is a meter stick, right? What do you think the density of this meter stick would be? Just give me an approximation. How did you guys know that? 0.00075 grams per cubic centimeter. So this is what you're telling me the density of this meter stick is?
No.
I asked you, what is the density of the meter stick? Yes?
It's a different kind of wood.
Let's just assume it's about the same type of wood. So are you telling me that the density of this meter stick is 0.00075 grams per cubic centimeter? Right? All right, now what is the density of this? But it's shorter. What is the density of this? What is the density of this? What is the density of this? Does it matter how much of a meter stick I have?
No.
No. What does it depend on? The substance. The substance hasn't changed, has it?
No.
Only the amount. And it doesn't matter how much of something I have. If I have that substance, I have the same density.